January 23, 1960. The Pacific Ocean. A Swiss engineer named Jacques Picard and a United States Navy officer named Don Walsh climb inside a steel sphere 6 feet across, 6 feet. You could touch both walls at once. They seal the hatch from the inside, and the ocean closes over them, and they start going down. The water darkens in the first 100 feet. In 300 feet, sunlight is gone. In 1,000 feet, the pressure outside the hull is enough to crush an unprotected human lung. But they are not stopping at 1,000 feet. They are not stopping at 10,000 feet. They are falling through the Pacific Ocean toward the deepest point on Earth, and they will not reach it for 4 hours and 47 minutes. Sit with that for a moment. Not the danger, not the engineering, just the duration. 4 hours of falling. Inside a steel sphere the size of a small bathroom, in total darkness, somewhere in the middle of the Pacific Ocean, in 1960. Then, somewhere below 9,000 meters, nearly 6 miles beneath the surface, they feel it. A crack. The entire vessel shudders. A plexiglass observation window is split. Picard and Walsh look at each other, and they keep going. That moment, 2 men in a shrinking steel room, 6 miles underwater, deciding to continue after the hull makes a sound no hull should make. That is the door into everything I want to show you today. Because what they went to find, what was waiting for them down there, is not just a depth record. It is a different world, a world that functions by rules the surface world does not use, a world that has been running its own economy, its own cycles, its own slow and vast and lightless life for hundreds of millions of years, almost entirely beneath our notice. The book that sent me down this particular rabbit hole is called The Brilliant Abyss by a marine biologist named Helen Scales. Published in 2021, it covers the deep sea in a way I had not encountered before, not just the creatures that live there or the machines we send down, but the political and existential question underneath all of it. What is this place? Who does it belong to? And what happens when we start pulling it apart? Scales writes with the precision of a working scientist and the instincts of a storyteller, and the book shook something loose in my understanding of what an ocean actually is. Because here's what I thought the ocean was before I read this book. A surface. A thing you cross. A horizon. Blue water extending to the edge of the world, deep in the abstract sense that you cannot touch the bottom, but essentially flat. The thing ships float on, the thing fish swim in, the thing that gives coastlines their smell and their sound. That is not what an ocean is. An ocean is a stack, a column of water miles tall, most of which receives no sunlight, most of which operates at pressures that would kill you in seconds, most of which has never been seen by a human eye. The surface layer, the warm, bright photosynthetic zone where almost all the life you have ever seen or heard about lives, is a thin skin stretched over something immense and dark and almost completely unknown. The ocean's surface is not the ocean. It is the ceiling of the ocean. And here's the thing about that distinction that I cannot get out of my head. Almost everything the surface produces goes down, and almost none of it comes back. There is a one-way door in the middle of the water column. Not a wall, not a barrier you can see, but a threshold, a point past which the physics and the chemistry of the deep seal almost everything inside. Not forever, not in a geological sense, but on the scale of a human lifetime, a civilization, a dynasty, effectively forever. There is water sitting in the North Pacific right now, as you listen to this, that has not touched the surface since before the Norman Conquest of England. It fell below the surface layer over 1,000 years ago. It has been down there through every war ever fought, through the Black Death, through every living person's lifetime. And it is not going anywhere. That is the thing I want to show you. Not just the depth, the mechanics of it. The reason that once something enters the deep ocean tends to keep it. Let me start at the top. Right now, this second, the surface of every sunlit ocean on Earth is doing something. The sunlight hits the top layer of water, the first 200 meters or so, the place where light can actually reach, and it powers a chemistry. Tiny organisms, mostly phytoplankton, microscopic and invisible, and numbered in the quadrillions, use that light to photosynthesize. They pull carbon dioxide out of the water, build it into their bodies, release oxygen. This is the foundation of almost all ocean life. It is also, and this is the part that opens the door to everything else, the beginning of a one-way conveyor. Because those organisms die, every one of them dies, and when they do, their bodies, still carrying the carbon they pulled from the water, begin to sink. They attach to each other, to fecal pellets from the animals that ate them, to long strings of mucus and organic debris. And that is exactly what it looks like through a deep-sea porthole, a snowfall. Constant, slow, falling in every direction at once, flakes of dead biology drifting through permanent darkness toward a floor miles below. The term marine snow appears in scientific literature as early as the early 1950s. The researchers who first lowered cameras and collection jars into the deep ocean kept pulling up organic fragments they couldn't account for. Bits of algae, fecal matter, strands of mucus that had clearly fallen a very long way to get there. Somebody looked through a porthole at the right moment and named what they saw: snow. A snowstorm that never stops, falling through a building 7 miles tall, settling on a floor that has not seen light in geological time. The exact story of who coined the name is uncertain. The history of the term is tangled enough that I'm not going to pin it on a single person, but the image it captured was exact the moment someone thought of it. The scale of this is genuinely difficult to hold in your mind. Estimates suggest that roughly 10 to 15 billion metric tons of organic carbon fall out of the surface ocean every single year through this process. 10 to 15 billion metric tons of the dead raining out of the lit world into the dark one. And an estimated 2 to 10 billion metric tons of that carbon per year sinks past roughly 500 meters and is effectively removed from the atmosphere for decades to centuries. Below that threshold, the carbon is out of contact with the air. It cannot exchange with the atmosphere. It has, for any practical human purpose, left the world above. This is what oceanographers call the biological pump, and the name is accurate in a way that becomes slightly uncomfortable once you understand it. A pump that runs in one direction, material goes in, and nothing comes back, not on any time scale that matters to you or your children or any generation you will ever know. The pump runs on sunlight. The destination of everything it moves is darkness. Most of this carbon sinks slowly. Individual phytoplankton cells, the smallest particles, fall at roughly 1 meter per day. At that rate, the deep ocean floor, averaging around 4,000 meters down, would take years to reach. But larger clumps fall faster. Fecal pellets, mucus-bound aggregates, the bigger pieces of marine snow. These fall at 100 to 200 meters per day. They reach the floor in weeks. Faster delivery means less time to be consumed on the way down, less time to decompose, more material arriving intact. And here is where the biology gets strange. The deep ocean is not empty. It is, and this is a fact that still catches me off guard, the largest single habitat on Earth. The ocean below 200 meters covers more than 80% of the ocean's area and accounts for roughly 95% of its volume. By sheer size, it dwarfs every other biome on the planet. The Amazon, the boreal forest, the Sahara, all of them together are smaller than the sunless deep. And life is down there. Creatures that have adapted to crushing pressure, total darkness, and water only a few degrees above freezing, existing on the marine snow that falls from above, manna from a heaven they have never seen. We have better maps of Mars than we do of the floor of this place. I want to say that plainly because it tends not to land the first time. Mars has been mapped at resolutions of around 20 meters per pixel across more than 60% of its surface. The seafloor of our own ocean, the floor of the largest habitat on Earth, is roughly 80% unmapped at any useful resolution for science. The United States Geological Survey has confirmed this explicitly. 140 million miles away versus less than 7 miles down. And we know more about the surface of the one that's farther. The reason is partially physics. Satellite radar cannot penetrate seawater. Mapping the seafloor requires ships and sonar, which is slow and expensive. But the comparison still says something about what we've prioritized. The deep ocean has been treated for most of human history as the background of the world, the empty darkness beneath the useful surface. Only slowly are we beginning to understand that the background is larger than the foreground, stranger than the foreground, and in some ways more important. Hold that, because I want to take you somewhere specific now, somewhere that the description of sounds like fiction and turns out to be perfectly, verifiably real. The Gulf of Mexico. About 1,000 meters below the surface, roughly 3 Eiffel Towers stacked end to end, the seafloor does something unusual in certain spots. There are ancient salt deposits down there, laid down during evaporation events hundreds of millions of years ago, now exposed by faulting or erosion. Seawater percolates into these salt beds, dissolves them, and forms a layer of brine so heavy with dissolved salt that it cannot mix with the water column above. It pools on the seafloor like a liquid inside a liquid. A lake at the bottom of the ocean. In 2014, a remotely operated vehicle launched from the exploration vessel Nautilus descended into one of these spots and found exactly that. A shimmering boundary at the bottom of the water column where the water became something else. Thicker, stiller, dense in a way the cameras could see. Fish and shrimp circling the edge were suddenly, visibly stunned, knocked sideways, unable to swim straight, and then, if they crossed the boundary, dead within seconds. Their bodies did not rot. A marine biologist named Eric Cordes from Temple University went back in 2015, this time using the research submersible Alvin, and what his team found around the rim of that pool has stayed with me ever since. A ring of preserved dead. Crabs, fish, creatures that had swum too close and died, their bodies sitting there, intact for what appeared to be years, possibly decades. The brine is 5 times saltier than normal seawater, saturated with methane and hydrogen sulfide, and the bacteria that would normally decompose a dead animal cannot function in those concentrations. Nothing eats them. Nothing dissolves them. They are simply arranged around the pool's edge like a border made of victims, in the dark, 1,000 meters down. Cordes and his team named this particular pool the Jacuzzi of Despair. The name is darkly funny and also exactly right. The chemical activity below heats the brine slightly. It is warm relative to the surrounding water, and it is a place from which the things that enter do not return. The salinity is the key. Normal seawater runs at roughly 35 grams of dissolved salt per liter. This brine pool runs at 5 times that. The boundary between the brine and the surrounding seawater is sharp, visible through the camera as a shimmer, a visual distortion like a heat mirage on a highway. A fish crosses that line and within seconds experiences an osmotic shock that is functionally equivalent to being dropped into industrial solvent. The water inside its cells is pulled outward faster than any compensating mechanism can respond. It dies. Picture the brine pool from above, the ROV camera angle looking down, the shimmering oval of denser water, the ring of dead animals arranged around its edge, nothing disturbing the surface, no decomposition smell because there's nothing to carry it upward. Total silence, total dark, except for the ROV's lights. The bodies have been there long enough to be covered in a fine layer of sediment. They will stay there until something physically disrupts the pool because there is no natural mechanism to reclaim them. This is, in miniature, what the deep ocean is, a place that holds what it receives because its chemistry makes return almost impossible. But if you want to understand what one way truly means at the scale of the whole ocean, you need to go somewhere far larger, somewhere that the numbers themselves are what unsettles you. The Black Sea. It sits between Eastern Europe and Asia Minor, a partially enclosed sea connected to the Mediterranean through the Turkish Straits. Rivers pour freshwater into it from all sides. That freshwater is lighter than saltwater, so it sits on top. The saltwater, denser, heavier, settles below. Because the basin is partially enclosed with limited connection to the open ocean, these two layers almost never mix. They have been stratifying, layer sitting on layer, for thousands of years. Below roughly 100 to 200 meters, the Black Sea has no oxygen, none. The oxygen that enters at the surface is consumed by bacteria in the upper layer and cannot be carried downward. There is no mixing, no convection, no mechanism to replenish it at depth. Below that boundary, the only chemistry operating is anaerobic, run by organisms that use sulfur instead of oxygen, producing hydrogen sulfide as a byproduct, operating in a world utterly alien to the biology you can see with the naked eye. Roughly 87% of the Black Sea's total water volume is anoxic, not low oxygen, not oxygen poor, containing essentially no dissolved oxygen at all. Most animal life, fish, crabs, jellyfish, everything you might picture when you think of the sea, requires oxygen. In the anoxic layer of the Black Sea, those animals cannot survive. Not as a question of adaptation or toughness, there is no oxygen to metabolize. The chemistry of aerobic life does not run, and the oxygen boundary has been rising. Estimates put the shift at roughly 20 to 25 meters upward over the past 2 decades. The anoxic zone is growing. The layer of water where aerobic life is possible is measurably shrinking in a sea the size of California. The Black Sea is the world's largest maromictic basin, a body of water that is stratified and non-mixing, but it is not unique in kind, only in scale. All over the world, in coastal zones and bays and estuaries, wherever fresh water meets salt water or where nutrient pollution pours in from land, the same process is playing out. Nutrient-rich agricultural runoff feeds algal blooms. The algae photosynthesize, die, and sink. Bacteria decompose them, consuming oxygen. The oxygen in the water column depletes. A dead zone forms. More than 400 coastal dead zones have been identified worldwide. Some counts now exceed 500. The Gulf of Mexico, downstream from the Mississippi River's agricultural runoff, produces one of the largest every summer. A region where the lower water column has been driven to near anoxic conditions, where fish and crabs flee and the slow-moving creatures that cannot flee simply die. The 2023 measurement of that dead zone came in at roughly 8,185 square miles. 8,000 square miles of water from which oxygen has been stripped. The biological pump, the brine pool, the anoxic zones, they are all expressions of the same underlying architecture. An ocean that stratifies, that separates into layers, that creates at depth zones from which the chemistry of surface life is simply absent. Not hostile in a dramatic sense, just absent. The way a room is absent of air when someone has quietly replaced it with something else. Which brings me back to Pickard and Walsh, and to what they found waiting for them at the bottom. After 4 hours and 47 minutes of descent, after the window cracked, after the shutter, after the decision to keep going, the Trieste touched the sediment at the bottom of Challenger Deep in the Mariana Trench in the Pacific Ocean. The best verified modern depth figure for that dive is approximately 10,916 meters, just under 11 kilometers, just under 7 miles. The pressure at that depth is approximately 1,086 times the pressure at the ocean's surface. The way that number is sometimes expressed is roughly 8 tons pressing on every square inch of surface, every square inch of everything. Your body, if it were there, would not collapse slowly. There would be no time to feel anything. The pressure differential would equalize your internal and external environments in a fraction of a second in a way that is not compatible with survival. The Trieste was built for this: 6-inch steel walls, a steel sphere with pressure-compensating fuel tanks. The observation window had cracked, not catastrophically but noticeably, and still they descended. They stayed on the bottom for 20 minutes. They turned on their floodlights and looked out, and Pickard reported seeing a flatfish lying on the sediment, staring up at the lights of the most isolated vehicle in human history. A fish at the deepest point on Earth. This detail has become famous, and it has also become contested. Some scientists who conducted subsequent dives to Challenger Deep have questioned the species identification. What Pickard saw may have been a sea cucumber or a holothurian, creatures that can survive extreme pressure by being mostly water with almost no rigid structure to compress. The species is disputed, and I want to say that plainly. But the sighting, an animal, on the sediment at the planet's deepest point is in Picard's own account. Life exists there. Whatever it was looking back. The Hadal Zone, everything below 6,000 meters, named for Hades, was not a dramatic naming choice. Modern oceanographers, when they needed a name for the deepest of all ocean zones, reached for the same word the ancient Greeks had used for the underworld. The word is the same. The mythology, it turns out, was anatomically correct. Challenger Deep itself sits at approximately 10,935 meters, give or take about 6 meters, based on the most careful modern measurements. The Hadal Zone spans from 6,000 meters down to that bottom. If you stood on the floor of Challenger Deep and looked up, the ocean surface would be 11 kilometers above you. You could take Mount Everest, the highest point on land, and drop it into Challenger Deep, and still have nearly 2 kilometers of ocean above its summit. Fewer than 30 people in all of human history have descended to Challenger Deep. Picard and Walsh were first in 1960. James Cameron made a solo dive in March of 2012, the first solo crewed descent and the fourth crewed descent overall, because there were intermediate dives in the decades between. A series of more recent expeditions has pushed the total toward roughly 27 or 28 people, depending on how you count. For most of modern history, more human beings had walked on the surface of the moon than had descended to the bottom of our own ocean. 12 people walked on the moon's surface during the Apollo missions. The numbers are only just now starting to approach each other. The moon is roughly 240,000 miles away. Challenger Deep is less than 7 miles down. The fact that those numbers have been roughly comparable, that we reached a rock 250,000 miles away, at roughly the same rate we reached the bottom of our own planet, is a fact about priorities in physics that I don't think most people have sat with. Here is why the deep ocean is harder to reach than space. Once you leave the atmosphere, space is essentially a vacuum. You are not pushing against anything. The engineering problem is getting there, not resisting the environment once you arrive. The deep ocean is the inverse of that. Every additional meter of depth adds more water weight above you. At Challenger Deep, the engineering task is not propulsion. It is building a structure that can resist 8 tons per square inch reliably for hours with people inside. The Trieste accomplished that in 1960, and then, for practical reasons of cost and complexity, almost nobody went back. Not because the technology stopped working, because the environment itself is an adversary, and a patient one. Now, I said at the beginning that there is water in the North Pacific that has not touched the surface since before the Norman Conquest of England. I mentioned it and kept moving. I want to come back to it now and tell you exactly what that means, how we know, and why the mechanism is the strangest thing in this entire story. The ocean circulates. You may have heard of the thermohaline circulation, the global conveyor belt, the system by which water cooled and densified at the poles sinks to the seafloor, flows along the bottom of the ocean over thousands of miles, and eventually, after a journey that takes roughly 1,000 to 2,000 years for a full circuit, rises back to the surface. It is a grand, slow, planetary-scale engine, and it is the reason the deep ocean is not simply stagnant, the reason the abyss is not just a permanent tomb for everything that enters. But that circulation has a structure. It operates at the deepest levels, below roughly 2,500 meters. The abyssal thermohaline flows are driven by the rough topography of the seafloor, by the friction of water moving over ridges and seamount chains. And it operates at the surface, the wind-driven circulation, the gyres, the Ekman transport, but that only reaches the upper few hundred meters. Between those two systems, at intermediate depths in the North Pacific, somewhere around 1,500 to 2,500 meters down, there's a layer that neither system reliably reaches. Too shallow for the abyssal currents below, too deep for the wind-driven currents above. It sits there, in permanent dark, in the middle of the water column with no efficient exit. In 2017, an oceanographer named Casimir de Lavergne at the University of New South Wales published a paper in the journal Nature identifying the physical mechanism that produces this effect. The abyssal circulation is shaped strongly by where the seafloor happens to be rough, by the ridges and seamounts and canyon edges that generate turbulent mixing as deep water flows over them. In the North Pacific, the geometry of the basin creates a region at intermediate depths that the turbulence below cannot reach and the wind above cannot reach. Water accumulates there. And it has, de Laverne's work showed, almost no way out except through slow molecular diffusion. Not circulation, not convection, diffusion. The same process by which a drop of ink spreads slowly through a still glass of water over hours and days. 4 years later, in 2021, Mark Holzer, Tim de Vries, and de Laverne published a follow-up study in Nature Communications that actually measured how long the water in this region had been down there. The concept they used is called ideal mean age, roughly the average time since each parcel of water was last in contact with the surface. Their findings cluster around 1,300 to 1,400 years for the oldest water in this shadow zone. 1,300 years. Let me put that in terms that mean something. 1,300 years ago, the people alive on Earth did not know that the Americas existed. They had no concept of phytoplankton or marine snow or the biological pump. There was no England as a unified country, just a patchwork of Anglo-Saxon kingdoms. The Abbasid Caliphate had recently emerged. The Tang dynasty ruled China. The Byzantine Empire was at a height it would never reach again. At that moment, water was crossing the surface of the North Pacific and sinking into the intermediate layer, moving below the reach of the wind, below the depth of thermohaline ventilation, into the shadow zone. And it is still there. Still in the dark, still at roughly 2 kilometers depth. It has been down there through the Crusades, through the Black Death, through the Renaissance, through every scientific revolution, through every human lifetime that has ever been lived since that moment. It will continue to be there for centuries more, leaking out through molecular diffusion so slow it makes a glacier look impatient. Scientists call this the shadow zone, not because darkness is unusual down there. Darkness is the default condition of the deep, but because it lies in the shadow of both circulation systems simultaneously. The word is almost poetic in its accuracy. A shadow is where you happen to be when the light doesn't reach you, not because anything is blocking it dramatically, but because of geometry, because of where you are relative to everything else. And I want to be precise here, because the framing matters. The water will eventually return. The thermohaline conveyor does cycle everything on timescales of roughly 1,000 to 2,000 years for a full circuit. The shadow zone is not a permanent geological trap. On a long enough timeline, the water surfaces. On a geological scale, this is a very slow circuit, not a sealed vault. But on the scale of a human lifetime, on the scale of a civilization, on the scale of everything we mean when we say a long time, it is a one-way door. The water that went down in the 7th century is not returning in the 21st. It is not returning in the 22nd. The carbon the biological pump has sent below 500 meters is not returning to the atmosphere in your lifetime, or your grandchildren's lifetimes, or any lifetime of any person you will ever meet. That is the honest framing. Not a permanent vault, a vault on any scale that matters to us now. Here is the cross-scale thread I keep returning to. The thing that feels, once you see it, less like a coincidence than like a pattern. Marine snow falls from the sunlit zone. Organisms die. Carbon sinks. The biological pump takes it below the reach of the atmosphere. Individual water molecules at the surface cool, densify at the poles, sink to the abyssal floor, join the thermohaline conveyor. Some of that water accumulates in the shadow zone for over 1,000 years before diffusing slowly upward. Organic matter that reaches a brine pool is preserved by hypersalinity for years, decades, maybe longer. The anoxic layer of the Black Sea has been accumulating the chemical products of anaerobic metabolism for thousands of years, expanding its territory upward as stratification deepens. At every scale, in every form, the same pattern. The surface produces and the deep receives. Photons power photosynthesis, carbon gets fixed, organisms live and die, their bodies fall. Water warmed at the surface eventually cools and sinks to the floor. Heat and light and chemical energy, generated at or near the surface, dragged downward by gravity and density and pressure, accumulating in a realm below that the sun cannot reach. The deep ocean is not the opposite of the surface ocean. It is the destination of the surface ocean. Everything the sunlit world produces, the darkness below, receives, holds, and buries, on any timescale that matters to any living thing. This is the point that Helen Scales is building toward in the brilliant abyss, though she arrives there through the question of who owns the abyss and what we stand to lose. Because the deep ocean is not just the planetary burial ground for marine snow. It is, she argues, the largest unprotected habitat on Earth, and it is an ancient one. The Hadal fauna, the creatures living in the trenches, evolved in geological isolation from each other, trench by trench over millions of years. The Mariana Trench and the Kermadec Trench and the Peru-Chile Trench host different assemblages of species, and exactly why is genuinely open science. The adaptations that allow life to function under the pressure of Challenger Deep are only partially understood. The distribution of deep-sea biodiversity, what lives where and why, remains one of the larger open questions in marine biology. What we do know is that life exists even at the planet's most extreme depths. The sighting in 1960, whatever the species actually was, established that in the primary record. Subsequent dives confirmed it and expanded it. Animals are living at 11 kilometers under pressures that would destroy every biological molecule we know from the surface world. And they are doing so using adaptations we are only beginning to understand, in an ecosystem that receives its food from the rain of dead falling from a world of light they have never accessed and never will. This is also where the research on brine pool margins becomes relevant, because the jacuzzi of despair is not entirely lifeless at its edges. Tube worms and mussels have been observed there, chemosynthetic communities that harvest the hydrogen sulfide seeping up from below, running on a chemistry entirely orthogonal to photosynthesis. They live at the margin of the unlivable, using the toxic chemistry that makes the pool deadly as their energy source. Not inside the brine, nothing aerobic can survive in there, but at the boundary where the chemistry transitions from possible to impossible, those creatures have carved out a niche. This is characteristic of the deep sea as a whole. Life finds the margins. The edges of anoxic zones, the chimneys of hydrothermal vents, the debris fields below whale falls, the rim of brine pools, wherever there is a gradient, wherever two different conditions meet, something has found a way to exploit the interface. The deep ocean is full of these marginal communities, and every time a submersible has visited one for the first time, it has found species that were unknown to science. Every mission returns something unexpected. Not because the deep ocean is poorly understood in theory, the physics and chemistry have been modeled with increasing sophistication, but because the sheer scale and variety of it is enormous enough that repeated exploration still keeps finding genuinely new things. Holzer and De Vries and de la Verigne's 2021 finding about the shadow zone matters beyond the poetry of it. It matters because carbon, the same carbon the biological pump is pumping downward right now at roughly 10 to 15 billion metric tons per year, follows the same physics as the water. Carbon sequestered below 500 meters is out of the atmosphere's reach for at least decades. Carbon that makes it to the intermediate depths of the North Pacific can join the shadow zone water on its 1,000-year isolation. The biological pump is the primary mechanism by which the ocean removes carbon from the atmosphere on timescales that matter to climate, and the shadow zone is one of the places that carbon goes when it gets there. This means the shadow zone, a geophysical phenomenon identified precisely only in 2017, with its water ages measured only in 2021, is not just a curiosity about how old ocean water can be. It is a key component in the carbon cycle, in the ocean's role as a climate regulator, in the question of how much carbon the deep ocean is actually holding and for how long. And we did not have a verified physical mechanism for it until 7 years ago. The seafloor record holds all of this. Sediment cores drilled from the abyssal plain contain layer upon layer of compressed marine snow, the accumulated dead of every surface productivity event since the oceans formed. Scientists read those cores the way you might read a geological diary. This layer corresponds to a productivity bloom, that one to a mass extinction, this one to a period of rapid cooling. The marine snow we are generating today will be in the record. The changes we are making to the surface ocean, warming, acidification, nutrient runoff, will change what falls. And what falls will be read millions of years from now as a record of what we did. The deep ocean does not forget. It cannot forget. That is the nature of a one-way door. I want to return to the numbers for a moment because the scale of what we don't know is part of the story. The Seabed 2030 project, an international initiative to map the entire ocean floor at useful resolution, has been working to close the gap. But as of the time I'm describing this, roughly a fifth of the seafloor had been mapped, a fifth of the floor of the largest habitat on Earth, and what has been mapped has returned consistent surprises. Hydrothermal vent systems supporting biologies that run entirely on chemical energy. Cold seep communities harvesting methane from the sediment. Manganese nodule fields covering sections of the abyssal plain for hundreds of kilometers. Seamount ecosystems dense enough to make fisheries researchers take notice. This is what makes Helen Scales's argument in The Brilliant Abyss so pointed. Commercial interests have identified those manganese nodules and cobalt-rich seafloor crusts as economically viable mineral deposits. The rare metals in them are real. The industry that wants to mine them is real. And the question of what would be lost, what species, what ecosystems, what millions of years of isolated evolutionary history would be scraped from the seafloor before we have any idea what we are scraping, is the question Scales is really asking, not just scientifically, existentially. We are considering industrializing a space that we have mapped roughly 20% of, that we understand perhaps a fraction of what we've mapped, and that took hundreds of millions of years to become what it is. The deep ocean has accumulated its dead for geological time. It has shaped the climate of the surface world for geological time. It has housed evolutionary experiments that took place over millions of years in crushing dark, producing organisms that are genuinely alien in their biochemistry. And the shadow zone water sitting at 2 kilometers depth in the North Pacific has been down there since before we had a word for ocean. We are the first species in the history of this planet that has had the ability to reach the bottom of Challenger Deep. We are the first species that has been able to look at the jacuzzi of despair and name it. We are the first species capable of measuring the age of shadow zone water and understanding what that age means. These are genuine firsts. They have happened within living memory, within the lifetimes of people who are still alive. The Trieste dive was 65 years ago. The shadow zone mechanism was identified 7 years ago. We are very early in our understanding of the largest habitat on Earth, and we are also at this exact moment beginning to make decisions about it. I want to slow down here, because there is something in the architecture of all of this that I keep finding myself circling back to, and I think it is the real point, not the deepest depth, not the oldest water, but the pattern underneath all of it. Take the biological pump. Sunlight hits the surface, phytoplankton photosynthesize, they die. Their carbon sinks. The energy of sunlight gets converted into biology, and then biology falls away from the light and is stored in the dark. The pump runs on solar energy and deposits its product in permanent shade. Take the thermohaline circulation. Water warmed at the tropical surface flows toward the poles, cools, becomes dense, sinks to the abyssal floor, begins the long, slow journey back. The heat of the surface world travels downward, is buried in the cold deep, circulates for 1,000 years before returning. Take the shadow zone. Surface water, caught in the right geometry of basin and depth and competing circulation systems, crosses a threshold and becomes isolated. It took the energy of surface processes to push it there, and then the surface processes can no longer reach it. Take the brine pool. Ancient salt deposits from surface evaporation events, sunlight, once driving water into vapor and leaving salt behind, now dissolved back into seawater and pooled on the seafloor. The chemical record of ancient surface chemistry, preserved in the dark at 1,000 meters, surrounded by creatures that entered and never left. Take the anoxic zones. oxygen, produced at the surface by photosynthesis, which runs on sunlight, consumed by bacteria at depth, not replaced because stratification prevents replenishment. The life-giving chemistry of the surface, spent and not renewed, leaving behind water that the surface world cannot inhabit. At every scale, in every form, surface generates, depth receives. Energy flows in, none flows back, not on timescales that matter. The deep ocean is not a separate system with its own independent logic. It is the terminus of the surface system. Everything the sunlit world makes, the darkness below archives. The relationship is not symmetrical. It has never been symmetrical. It is the relationship between a forge and a slag heap, except the slag heap is the size of a planet's largest biome, and it is full of life. This is the cross-scale echo that the biology of the deep makes strange, because the creatures down there, the animals that eat marine snow, that crowd around hydrothermal vents, that live at the rim of brine pools, they are not victims of this arrangement, they are its beneficiaries. The one-way door is their food delivery system. The burial chamber is their home. They are alive because the surface world produces and drops its dead into the dark, and they have spent hundreds of millions of years evolving to receive it. The tube worms at the brine pool margin, the snailfish that have been filmed in the deepest trenches, pale, gelatinous, not compressing under pressure because their bodies are mostly water and their bones are soft enough to flex rather than shatter. The holothurians, the sea cucumbers that crawl across the abyssal plain and process sediment through their bodies the way earthworms process soil, consuming the marine snow as it accumulates on the floor and cycling its nutrients back into the water column. The amphipods found in the deepest trenches that, when studied, turned out to carry in their bodies traces of man-made chemicals, persistent organic pollutants from the surface world, absorbed from the marine snow that carried those chemicals down from above. The deep ocean fauna are eating our pollution. It rained down with the marine snow, and they consumed it, and it is in them now. That finding, from studies of hadal amphipods in the Mariana Trench, is one of the stranger ones I encountered when reading around this topic. The deepest animals on Earth, in one of the most remote environments on Earth, carry chemical traces of human industrial activity. Not because humans sent anything down there directly, because the biological pump does not discriminate. It carries everything the surface ocean contains, organics and pollutants alike, downward into the deep, and the creatures of the deep consume what falls. The one-way door is not selective. It moves everything. I want to think about what that means for the moment we are living in. The surface ocean is changing. Warming, acidification from dissolved CO2, shifting productivity patterns as temperatures and nutrient flows change. What grows in the surface ocean determines what falls, and what falls determines what the deep ocean receives. The biological pump's output is not fixed. It responds to what is growing in the sunlit layer. If the species composition of phytoplankton changes under warming, the particle size and sinking rate of marine snow changes. If productivity shifts geographically, the rain of dead falls differently on the seafloor. The deep ocean, which operates on timescales of centuries to millennia, will receive and archive the record of surface changes for longer than any living human civilization will exist. The sediment cores already tell this story, working backward. Layers of compressed marine snow record every productivity event, every extinction pulse, every period of surface warming and cooling for hundreds of millions of years. The creatures that grew, died, and sank in the Cretaceous are now chalk. The creatures doing the same thing today will be something similar in geological time. The archive is continuous. It has never stopped recording. And this brings me to a scale problem that I find quietly staggering. The deep ocean operates on timescales that are fundamentally out of register with human experience. The shadow zone water is 1,300 years old. The thermohaline conveyor takes 1,000 to 2,000 years for a full circuit. The marine snow falling today will be sediment in centuries. The chemical changes we are making to the surface ocean will propagate into the deep, through the biological pump, through changing circulation patterns, through altered marine snow composition, and they will be felt down there, and they will be recorded there, long after every institution, every nation, every language we speak today has ceased to exist. The deep ocean is running on deep time. We are running on human time. And our decisions about the surface ocean, what we put into it, what we take out of it, what we warm it by, are being written into a ledger that operates on a completely different clock. This is what Scales means when she talks about the stakes of deep-sea mining. It is not just that we might destroy species we haven't cataloged. It is that we would be disturbing systems that took millions of years to develop, operating on timescales that make industrial planning cycles look like blinking. The manganese nodules on the abyssal plain grow at a rate of roughly a centimeter every million years. They are among the slowest growing formations on Earth. Mining them would remove them on human timescales, years, decades, and they would not return on any timescale that means anything to us. What took 10 million years to accumulate could be scraped away in a season. The one-way door works in all directions in the end. Once you remove something from the deep-sea ecosystem, it does not come back. The ecology of the abyss, evolved in isolation, operating on deep time, adapted to conditions that took the planet billions of years to create, does not have a reset button. It has a memory in the sediment, in the genetics of its creatures, in the chemical gradients of its water. But a reset? No. We are used to thinking of the ocean as resilient, and in certain ways, on certain timescales, it is. The thermohaline circulation has survived mass extinctions. The biological pump has persisted through warming events that would be catastrophic by modern standards. The deep sea has been hit by bolide impacts, by volcanic winter, by anoxic events that killed most surface life. And life has persisted in the deep, in some form, because the deep is buffered from the surface. The same isolation that makes the shadow zone water ancient also made deep sea life a refuge during surface catastrophes. But resilience on geological timescales is not the same as resilience on human timescales. And the pressures we are placing on the ocean are arriving faster than geological processes can absorb. The oxygen minimum zones are expanding. The dead zones are multiplying. The ocean is warming at depth as well as at the surface, changing the density gradients that drive thermohaline circulation, potentially slowing the conveyor that ventilates the abyss. What happens to the deep ocean when the circulation that delivers oxygen to the abyssal floor slows down is not a question with a reassuring answer. I said earlier that I would come back to the seafloor map. I want to come back to it now because the number 80% unmapped at useful resolution is doing more work than it might seem. When we say we don't have a map, we don't just mean we don't know what the bottom looks like. We mean we don't know where the vents are. We don't know the full distribution of cold seeps. We don't know which seamounts host which endemic species found nowhere else on Earth. We don't know the extent of the microbial mats on the abyssal plain or the full community composition of Hadal trenches other than the handful that have been visited. We don't know, in any systematic way, what we would be destroying if we began mining the abyssal floor. This is the situation Helen Scales is describing in The Brilliant Abyss, and she describes it with a frustration that is entirely earned. We are not being asked to decide whether to develop a place we understand well. We are being asked to decide whether to develop the largest habitat on Earth at a moment when our map of it covers roughly a fifth of its area, and when the exploration science required to fill in the rest would take decades at current pace and funding. The comparison to Mars is not just about priorities. It is about what we have treated as urgent, what we have treated as belonging to us, what we have treated as ours to decide. Mars has no life as far as we know. The seafloor is full of it. And the life down there has been doing something for a very long time, something quiet, vast, and essential. The biological pump sequesters, estimates vary, but roughly 2 to 10 billion metric tons of carbon per year, out of the atmosphere and into the deep. This is the primary mechanism by which the ocean moderates the carbon cycle on meaningful timescales. Without the biological pump, atmospheric CO2 levels would be dramatically higher than they are. The marine snow falling right now, this second, From every square meter of sunlit ocean, all of it, the tiny fecal pellets and the dead cells and the mucus aggregates and the bodies of things too small to see, is performing a planetary-scale climate function. It is not symbolic. It is not metaphorical. The rain of dead from the sunlit ocean into the dark ocean is one of the reasons the atmosphere is breathable. The creatures that produce the marine snow, the phytoplankton, the tiny grazers, the entire sunlit food web, are not being asked to do this. They are doing it because they live and die. Their biology has always done this. They have been doing it for hundreds of millions of years, and in doing it, they have shaped the atmosphere of the planet for the entire history of animal life. We evolved in an atmosphere that was partly maintained by the death of phytoplankton. Our lungs work in air that is partly the product of marine snow. The deep ocean receives the dead. The surface ocean receives the oxygen. The exchange has been running since before complex life existed. It will keep running in some form long after we are gone. But we are here now. We are the first species to be able to understand this system and the first species capable of disrupting it at global scale, and those two things have arrived at the same moment. The understanding and the disruption are simultaneous. That is the thing I can't quite find a comfortable frame for. What Picard and Walsh went down to find in 1960 was not just a depth. They went to see whether life existed at the deepest point on Earth and whether a human being could survive the journey to find out. They answered both questions, and then they came back up, and the world continued for decades, largely unaware of what had been established. The deep ocean remained in the background, in the dark, doing what it does. The shadow zone water that has been isolated since the 7th century does not know any of this. It is not doing anything. It is simply sitting at 2 kilometers depth in the North Pacific, in the geometry of competing circulation systems, going nowhere in particular for another 1,000 years. It has no stake in our decisions. It is not watching. But we have a stake in it, because that water, and the carbon dissolved in it, and the marine snow raining toward the sediment above it, and the creatures living in permanent dark, eating what falls from the sunlit world, all of it is part of the system that makes the surface world livable. The deep ocean is not the background, it is the foundation, and we have maps of Mars. There is something I want you to sit with before we go any further. Something about your own body and your own position in all of this. You have carbon in you. Right now, in your cells, in your bones, in the molecules that make your brain capable of hearing these words. There is carbon. That carbon has a history. It has been part of other things. At some point, in some form, carbon that is now you was once in an organism that died and began to sink. Some of it sank slowly. Some of it was consumed by things below and recycled back up before it reached the deep. Some of it, in a past life measured in millions of years, not one, sank all the way, reached the sediment, became part of the geological record, was subducted into the mantle, released by volcanism, entered the atmosphere, was photosynthesized again, entered a food chain, and eventually, over timescales so long they are barely meaningful, became part of something alive again. The carbon in you has done this in some form for billions of years. You are a temporary arrangement of atoms that have cycled through the biological pump, through the deep ocean, through sediment and rock and atmosphere, and ocean surface again countless times. You are made of deep time. And when you die, not symbolically in the long view, the carbon in your body will re-enter the cycle, not into the ocean directly, most likely, but into soil, into atmosphere, into the food chain, and eventually some fraction of it will find its way to the surface ocean, into a phytoplankton cell, and from there, when that cell dies, into a particle of marine snow, and from there, slowly, over months or years or decades, into the deep. Your carbon will become marine snow, not soon, not in any way you will notice, but eventually, statistically, inevitably. The biological pump does not stop running. I want to end where we began. January 23rd, 1960. A steel sphere 6 feet across, 2 men in the dark, 6 miles down, in a vessel that has just cracked and shuddered and given them every reason to stop. And they don't stop. They go to the bottom, and they turn on a light, and something looks back at them. I think about that moment more than is probably reasonable. Not the engineering, not the record, the looking. A light in the deepest dark on Earth, and something already there. Something that had never seen light before, in water that had not touched the surface for longer than written history, turning toward it. The deep ocean did not need us to find it. It had been running without us for hundreds of millions of years, cycling the dead downward, preserving what it received, conducting its slow and lightless economy in the permanent cold. The marine snow was falling before there were eyes to see it fall. The shadow zone was accumulating ancient water before there was anyone to measure its age. The brine pool was killing and preserving its visitors long before a remotely operated vehicle descended with cameras and named the place. The anoxic layer of the Black Sea was expanding in silence. We arrived very recently. We looked. We are still barely looking. And what we have found, in the time we have been looking, is this. The thing that looks like the bottom of the world is actually the destination of everything that lives at the top of it, every organism that dies in the sunlit ocean, every particle of carbon fixed by a phytoplankton cell, every degree of surface warmth that eventually cools, sinks, and joins the conveyor. All of it goes down. Almost none of it comes back, not on any clock you or I will ever live to complete. The deep ocean is where the surface ocean sends its dead, and its secrets, and its record. It is the largest habitat on Earth and the least seen. It is where life goes when the light runs out. Pickard and Walsh stayed at the bottom of Challenger Deep for 20 minutes. Then they began the ascent. 3 hours and 15 minutes back to the surface, back to the light, back to the thin, bright skin of the world where we live. They brought nothing back with them except the knowledge of having been there. The flatfish, or whatever it was, stayed. Right now, in the North Pacific, at roughly 2 kilometers depth, water that was at the surface when the Normans hadn't yet crossed the channel is sitting in the dark, going nowhere. Marine snow is falling from every square meter of sunlit ocean, carrying the dead downward at 100 meters a day. The jacuzzi of despair is surrounded by its ring of preserved dead, undisturbed, in a darkness we have glimpsed exactly once. The surface of the ocean glitters, it moves, it catches light, and beneath it, beneath all of it, the deep is doing what it has always done, receiving.